So part C, you're going to be writing up as a regular experiment in your lab notebook. So this is the equipment you would use in real life. So I'm going to be doing this on a computer simulation, but I want to show you the equipment in real life so that you understand what the simulation is supposed to be modeling. So the first piece of equipment we have here is called an optical bench. You can also just call it the track. So it's got a numbered scale on it, and on one end of it, we've got a light bulb mounted. We also have various things that we're going to be able to put into these movable holders that are on the optical bench. So I can, for example, screw something here in place, like that. The first thing I'm going to add to the optical bench is this guy here. So this is called the object, so the object screen, and it's just got a little pair of arrows cut out of it, and it's going to go right beside the light bulb, and then we're basically going to have arrow-shaped light leaking out past this. In this part of the experiment, you're going to be studying both a lens and a mirror. And to begin with, we'll start with the lens. So that's mounted on a holder here. It goes in the middle of the track like this. And then what we're going to do is we're going to turn on the light bulb. So the light is going to be leaking through that arrow cutout. It'll hit the lens. We should be able to get a focused image of the arrows. So that's not going to be super easy to see in the video. So here's a close-up of that. So here's a close-up of our lens. And I put the image screen on the track, and you'll notice that in most locations, everything's pretty fuzzy there. But if I move my card to exactly the right spot, I get a nice sharp image of those arrows on the screen. So your job is to put your lens in some location on the track, and then you move the screen back and forth until you find the most focused image. What we're going to do in this experiment is you put the lens in the middle of the track, you go and find a focused image, and then there's two quantities we need to measure off of the track. One of them is called the object distance. That's from the lens to the object, this screen. And the other is the image distance. So from the lens to the focused image over here. So image distance is lens to image. Object distance is lens to object. So it all gets measured relative to the lens. So you would get the object distance and the image distance. And then you move the lens somewhat down the track, say about 10 centimeters, and you do it again. You go and find a nice in-focus image, and then you record your object distance and your image distance. So you're writing this down in your notebook as data. And then you go another 10 centimeters down the track, find a focused image, and again record the object distance and the image distance. And you go right to the end of the track as much as that's possible. Find your focused image, record the image distance and the object distance. Now what we're actually looking for in this part of the experiment is the focal length of the lens. Focal length is something that's actually determined by how the lens is manufactured. So it has to do with the curvature of the sides of the lens. So we're trying to determine the focal length of that lens using this data that we just took. We're also going to do this again for the mirror. So we've got a curved mirror here. Again, light leaks through the arrows, hits this mirror, and it's going to bounce back in this case. So what we do generally here is we would tilt the mirror just a little bit, and then we'd be able to catch a focused image on the screen over here where you wouldn't be able to see it. So let me show you a close-up of that. Okay, so this may look a little confusing at first, but this is our mirror. This is the back of our mirror right here, and we're looking back towards the light bulb here. So this is our object screen. So the light is traveling from the object to the mirror, and then it bounces back, and we should be able to catch an image over here. So I get my card in here, and I move it back and forth, and I find that again, if I'm too close to the mirror, everything doesn't look in focus. If I get too far away, it's still not in focus, but if I move the card to exactly the right spot, I get a nice, sharply focused image of the arrows on my screen. So you would place your mirror in some location, move the screen back and forth until you get a nice, sharply focused image, and then you record your image distance and your object distance. Again, in this part of the experiment, you should put the mirror somewhere in the middle of the track. You go and find the focused image, and then you record your object distance and your image distance. And again, the object distance is measured from the object to the mirror, and the image distance is measured from the mirror to the image. So it all gets measured relative to the mirror. So image distance, object distance. And again, you move the mirror 10 centimeters down the track, go and find a focused image again, record your object distance, your image distance, do it again. and you just go all the way down the track recording your object distance and your image distance. And then you'll be able to determine the focal length of your mirror from that data. So now let me again show you all of that in the simulation. If you haven't done so already, click on the first drop-down menu and make sure that you're set to Part C of the simulator. So over here on the left-hand side of the screen, we've got our fake light bulb and our fake object screen. And then we've got our lens, which we can move back and forth, and also a screen, an image screen, where we can focus our image. So to begin with, you're going to put your lens somewhere in the middle of the track. I suggest about 30 or 40 centimeters. And then you want to move your image screen back and forth until you get the sharpest possible image focused on it. And by the way, there is also a magnified image down here in the corner to help you see when that image is exactly focused. So I'll get this as focused as I can. And then what I would record in my book would be the object distance, so the distance from the lens to the object screen, and the image distance, which is the distance from the lens to the image when the image is in focus. Now the simulation actually calculates the image and object distance for you, but if you ever get things positioned such that you can't read the image distance or the object distance, you can actually calculate them yourself. So the image distance is just the position of the image screen, which is written down here, minus the position of the lens, which is written down here. So you can calculate the image distance and the object distance yourself just from these positions. So you get your image as in focus as you can, and you write down the image distance and the object distance, and then you're going to move your lens 10 centimeters down the track, and again, go find the image when it's in focus, and record your object distance and your image distance, preferably in a table. And then you just keep doing that, moving your lens 10 centimeters down the track, and finding the focused image. And you should go right to the end of the track. So for your last data point, put the screen right at the end of the track and then move the lens around until you get a nice sharply focused image, even though that won't give you a nice even increment of 10. Now another thing to watch out for is that you will notice that sometimes you can't be totally exact about when this is exactly in focus. Do the best you can with this, and understand that even though this is a limitation of the simulation, it happens with real equipment too, that you have a little bit of trouble finding when the image is exactly in focus. So you record all of this information, and then you're going to find the focal length of your lens from the data. Now once you're done with all of this, you're going to switch to the concave mirror. So now we've got the mirror over here, and we move the image screen back and forth to get a focused image. So again, I recommend you start with your mirror about 30 or 40 centimeters from the object screen, and then you move your image screen back and forth until you get a nice sharply focused image. And then again, you move the mirror 10 centimeters back and get a nicely focused image again, and record all of your image and object distances. And again, go right to the end of the track for your last data point and move the screen around until you get a nice sharply focused image. And once you've got all that data, then you can find the focal length of your mirror. Now at this point you might be saying, well, how am I supposed to find that focal length? Because you haven't actually told me that. Well, I'm not going to either, but I will point out that if you open up the lab manual, then you'll notice that at the top they give you the objective that you need for your lab notebook. And if you scroll down a little bit, there's some theory here. And this theory does contain the information you need to figure out what the focal length of your lens and your mirror is based on the data that you just took. So I do recommend that before you start, you open up the lab manual, read through the theory, and then you'll actually follow through these steps in the procedure to take your data. And there's a good reason to do that as well, in that there are some questions here that you need to answer because they're also worth marks, and I didn't cover them in my video. So always go through the procedure of the lab manual when you're doing the experiment. So they guide you through placing the mirror, getting things in focus, taking your data, changing the position of the lens, taking more data. They ask you a few questions about what happens to the image. You continue on, find the focal length of your lens, and then you repeat it all for the mirror. So just work your way through the procedure of the lab manual. When you're done, you're going to write up an analysis, and it'll be a very simple one because we didn't compare any values to each other with a % discrepancy this week. So all you need in your analysis is to say the focal length of the lens was and give a value, and the focal length of the mirror was and give your other value. And that's all you need for your analysis this week.